Okay, powers of products and quotients with integer exponents. Integers just mean that the exponents are whole numbers. And even though this is focused on product to a power or quotients to a power, those two specific rules, there are other rules involved in this one. So it can be complicated if your exponent rules are a little shaky because you have to combine a bunch of them. But they should all start out with either raising a product or a quotient to a power. Here it's a product, right? Product's just a fancy word for multiplication. So we've got a multiplication of, oops, that's pretty bad. We've got a multiplication of this thing times this thing, and I'm raising that multiplication to the negative fourth power, which means that I should raise each of them individually to the negative fourth power. It's kind of like the distributive rule for exponents. When you're doing multiplication, if you're multiplying by 3, that can distribute over addition, subtraction. Exponents kind of distribute over multiplication and division. But then the tricky thing is you have to invoke another rule. 9 to the 6th to the negative fourth power is really a power to a power, which means that you end up multiplying the exponents together. So this is going to be 9 to the negative 24th. Okay, and then 7 to the negative 9 to the negative fourth. Again, we multiply those exponents and we get 7 to the 36th. Okay. 36th. I can do that a little better. Okay, not much, but okay. So 9 to the negative 24th times 7 to the 36th. Well, this looks like it's almost the answer, except the signs are switched on the exponents, so it's not good. This one, they end up with a fraction all of a sudden, and there's no fraction here. But this is actually going to be the answer right here. The reason is it's got 7 to the 36th, which looks right, okay? But instead of having 9 to the negative 24th, it has 7 to the 36 over 9 to the 24th. But you see what's happened is this is the example of the negative rule. If you have a negative exponent, you can always turn it positive by changing its side of the denominator. So really what we're doing is we're making this 9 to the positive 24th by, that should be an arrow, dropping it in the fraction here. Okay, so that's why this one's the answer. Okay, now this is a quotient. Quotient is just the fancy word for division. So I've got a division of two things raised to a power. But the notion is similar, right? Exponents distribute over both products and quotients. So I'm just going to raise the top and the bottom of the fraction to the 7th power individually, right? So I'm going to just raise this to the 7th and this to the 7th. And again, each of these things have exponents, so I'm really raising an exponent to another exponent. So we'll have to use the power to a power rule. 2 to the negative 10th to the 7th power is really 2 to the negative 70th. I multiply those two exponents together. Okay, that's a bad 2. Okay, and then over here we've got 4 squared to the 7th power. Again, that's just multiplying the 2 and the 7 together. That's 4 to the 14th. Okay. All right. So now we have to decide which of these is really going to be our answer, right? And this doesn't look right because it only has a 2 in it, and this doesn't look right at all. What they're trying to catch you on here is whether you're going to add the exponents together, which is incorrect. But here we have the 70th and the 14th like we do up here, but somehow the 2 to the 70th has been dropped in the fraction. Again, that's just the use of the negative rule. I can always change the sign of the 70 by moving it in the fraction to the other side of the fraction. Here I'm moving it down, so it becomes positive. So it's and if you move everything on one side of the fraction, there's just a 1 there that remains. So there's a 1 up top, and then a 2 to the 70th times 4 to the 14th. Okay. Again, ask yourself, do I have a product or a quotient? This is a quotient. It's a division. Okay. And I'm going to go a little faster here. So I'm raising both the top and the bottom to the 4th power. I'm going to multiply the exponents. So I just get a to the negative 12th. And then b to the 8th. B to the 8th. That's a silly looking b. Okay. And this isn't right? This doesn't look close to being right. This is, again, I'm not even sure what they did. Oh, this is seeing if you added the exponents instead of multiplied them. But this one ends up being right. It's got the 12th and the b to the 8th. The a is not in the same place, but that's because they turned the negative 12 positive by moving it down to the bottom of the fraction, just like they did in the last problem. Okay. Let's see. Okay, back to a product, right? This is two things being multiplied together, raised to a power. Again, I'm going to speed up a little bit. I'm just going to raise each of these things to the 5th power, multiplying their exponents by 5. And I'm going to have, 2 to the negative 20th. And then z to the negative 15th. Here we have both of them being negative, okay? So if they wanted to turn them positive, they'd have to move them downstairs in a fraction, okay? So that's this answer right here. This one's not right because they have a different sign of exponent and they haven't moved it in the fraction at all. They've left it in the numerator level. Here, this isn't right here. This is probably, a lot of people have the tendency to want to multiply these two things together, which you can't, right, unless the bases are the same. So it's just this, the answer is A here. So I hope that helps a little bit on this tricky skill. Let me know. It really does. It's trying to focus on one exponent rule, but it really combines like 3 of them together to finish the problem.